Hello, welcome to my AWS Cloud Quest playthrough. So today I'm going to be playing through the entire Cloud Quest Cloud Practitioner. It's a really fun way to learn AWS. I mean, it gamifies a lot of the stuff you need to learn for Cloud Practitioner exam. If you're here for a specific part, I will have the chapters here so you can go to the specific part you might be stuck on. Otherwise, if you want to watch me play the whole thing from start to finish, then you can watch this whole video. I'm also going to be creating a playlist with just individual parts of this the Cloud Quest Cloud Practitioner. So yeah, without further ado, let's get started on this playthrough. All right, so let's see what this guy right here wants. All right, so we got our first mission, Cloud Computing Essentials. What a sad sight. The beach is totally empty. I'm counting on you to solve this. So our learning objectives is to create a S3 bucket, looks like. So video concepts, I've already watched these. Might be worth, I recommend watching them. We have here the architecture, which will walk us through. So city residents, city web portal, we have an S3 bucket here, bucket policy. Cool. So we're gonna click to the plan section.
This is the plan section.
Again, skip this. So practice lab goals, review bucket policy to secure a bucket in Amazon S3, and we're trying to enable static web hosting. So the next part we're going to go to 3.
This is the practice.
Which is going to be our lab. So you can see there's 18 steps to this lab. It's step by step. We're going to click Start Lab and then click on Open AWS Console. Let me exit full screen mode. So this is going to open up a kind of console window up here. Inside this lab environment. All right, so let's go back to Cloud Quest, see what they want us to do here. Okay, we'll go to the next step. All right. So it's going to always begin with AWS lab user. Cloud Quest will provision a lab account for you. Okay. Click Start Lab. Okay, and then you click this to open the console. All right, so this is all pretty straightforward. It's just about how to open the labs, since this is the very first one. So it's going to give us step by step what it wants us to do. So first it wants us to open up S3 bucket. So it's telling us to search and then click on S3 bucket. And then we should see 3 buckets here. And it wants us to click on this one, website bucket. So let's do that. So here we go. Here's mine, website bucket. We'll click on that. Go to next step. All right. So it wants us to copy this website bucket. Copy that. Fine. And then what do you want me to do? You want me to review this. Okay, choose the text.html and then click rename object. Okay, so click text HTML and then we'll click on rename object. All right, what next? All right, they want me to rename it to error.html. All right, fine. Rename it to error.html. Save changes. Okay. See what's next. in the success alert, review the message, click on permissions, go to the next tab. Okay, fine. So we got success. They want me to go to permissions. Let's see what you want me to do in permissions. Review, scroll down. Okay, fine. Review, scroll down. Okay, so review. All right, here's our bucket policy. Okay, what now? Properties. Okay, you want me to click on, we're going to click on properties, and we'll scroll down to the static website hosting and then click on edit. All right, static website hosting. There we go. Should be at the bottom. Click on edit. So we want to enable and then host a static site. Okay, enable, host a static site. Index document, we want index.html, and then error document, we want error.html. Okay. Cool. What now? All right, scroll down and then save changes. Okay. Scroll down, review, copy. They want us to copy the under bucket website site endpoint. Click the copy. Okay. Where's bucket website endpoint? Where's that? Here we go. It's at the very bottom. All right, so they probably want me to go to that website. Yeah. All right, so new tab, and we're going to just paste that static page here. And there we go. All right, we get this beach wave condition website, just like in CloudQuest. All right, so what's next? Okay, so that's the lab completed. Now we need to do the DIY section. So the DIY section.
Finally,
don't want you to watch this. DIY section, they're going to ask us to do something here. So they want us to rename index.html to wave.html, and they want us to put the bucket name in here. All right. So if we take our bucket right now, website bucket, this one, or whatever, whatever your bucket is, paste in here. And if you click validate, it should tell us that we're not good yet. Yeah, could not find waves HTML in the bucket. Check that you renamed the file as requested in the DIY. So this is the DIY section where it tests you. We need to rename index to wave.html. So let's do that. All right, well, that was where in objects. Yeah, we don't have a index.html anymore. We changed that index.html to error.html. I mean, I guess wouldn't we just rename error.html to waves.html? Let's see. Yeah, all right. So that's done. See if I broke the website though. That's what they asked, to rename index to waves. I guess we're done. Exit. So that's the first one completed, and we get a reward. All right, let's see what you're going to give us. Thank you for providing a quick and effective solution. You're welcome. It looks like the beach crowd is returning. So we get to choose a lighthouse. I'm going to choose this one because it's the biggest one. Cool. So Pinky Cloud is now level 2. Um, all right, so that was S3. And let's go to the next one, Cloud First Steps. All right, so we're going to do the Cloud First Steps playthrough. Hi, I'm sorry. Our encounter is during an emergency, but we have a major issue to deal with. No problem at all. I've heard that the city's stabilization system is malfunctioning. That's right. The computational module in our stabilization system is controlled by a physical server, and yesterday the hard disk started to show signs of failing. I ordered a new hard drive, but it will arrive in 48 hours, which might be too late. The stabilization system problems are causing tremors on the island. What would you recommend? Okay, I think we can use an Amazon EC2 to solve this problem. Amazon EC2? What is that? Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides reliable, scalable compute capacity in the cloud so that you can launch virtual servers in minutes. That sounds promising. Can you tell me more how I can improve server resilience? As you mentioned, devices can fail at any time. To help improve server resilience, you can use AWS infrastructure to place Amazon EC2 servers into 2 different availability zones. Availability zones, do you mean 2 data centers? Not quite. An availability zone, or AZ, is a logical data center in an AWS region that has redundant and separate power, networking, and connectivity. Each AZ is supported by 1 or more physical data centers. I like what I'm hearing. This sounds very resilient. Yes, AWS infrastructure is very reliable. I can help deploy this solution and get your island back to normal. Thanks for the advice. I'm eager to start. Are you ready to deploy 2 Amazon EC2 servers? All right, so this mission, we're going to be launching 2 EC2 instances into 2 separate AZs in the same region. So let's accept this. Great, I have confidence in you. All right, you better have confidence in us. Okay, so you have the video concepts about like what EC2 is, and the well-architected framework, which is definitely important for the Cloud Practitioner exam. I think they have a bunch of questions about this specifically. But yeah, I'm not going to watch those. Let's just get right into this. So the island wants to improve reliability. We're going to have AZ B, AZA, and it's going to be, this is all US East, and we'll do 1A, 1B. And we're going to have EBS volumes, all right? So EBS is an efficient, high-performance block storage service designed to use with EC2. Okay, cool. So let's go to the next part. So launch an EC2 instance. Configure a user data script to display the instance details in a browser. And then in the DIY section, we're going to launch a second EC2 instance in a different availability zone of the same AWS region. So you can see in this architecture, all this stuff is contained in one region. All right, let's get to practice. Okay, so let's get this lab started. All right, so start your lab. There's going to be these lab files, so you're going to want to click on download. So download that user data. We'll need that for later. So once our lab launches, we're going to create an EC2 instance. Okay, so our lab's finally ready. So we're going to click open AWS console. And then we're going to want to click on EC2. All right, so that's going to load. We're going to want to launch an instance. So click launch instance. What next? We're going to call our instance web server 1. So we'll write that for the name, web server 1. For the image, we're going to do Amazon Linux. The Amazon machine image, let's see what they want us to pick for that. They want us to pick this Amazon Linux 2 AMI. Okay. And then for instance type, we're going to be using t2.micro. Okay, scroll down. We're going to edit our network settings. So click edit. And then here they want us to choose the subnet and the VPC. Now, you need to make sure you're creating this in the right region. So they're doing this in North Virginia, so US East 1. So make sure you are in that region. And the first time I did this, I made this mistake where you need to pick the right VPC. So the VPC we want is this Cloud First Steps, this VPC right here. And now we need to look through the subnets, and there should be a 1A subnet. Yep. So we're launching this in this this region, US East 1, and inside of 2 different AZs. So the first instance, we're going to launch in US East 1A. So we'll select that. All right, so next, give the security group a name, call it security group. What do you want me to call it? Security group lab. I'll call this HTTP lab group. Okay, and then type will be HTTP. So pick that. All right, source type anywhere, port range 80. Okay, should be all good there. Configure storage. So it's already set to GP2. Then we're going to want to click on advanced details, okay? So let's open that up. What do you want me to do in advanced details? All right, so they want us to upload this this thing. Okay? So this lab file. So if you scroll all the way down, you'll see this user data, and they want us to choose this file. I actually opened it in Atom. It looks something like this, the lab file. So we're going to choose a file, and then we're going to go find that lab file. All right, I downloaded it twice. So this is the one we're going to be using, user data 1. All right, so there we go. I loaded in user data. So the user data launches a web server using port 80. Okay, cool. Yeah, we just did that. Uploaded that in there. Review it, and then launch instance. Okay, so let's launch the instance. Oh, whoops, my bad. I forgot one thing. In the key pair, they just want us to click proceed without a key pair. All right, so now we're ready. Launch that instance. Okay, so this will take a moment to launch. Okay, success. So go back to instances, and you can see the instance state is pending currently, so we'll give that a moment. Let's see. All right, so yeah, it wants us to go back to instances, and then they want us to click on copying this public IPv4 DNS and then paste it in a new tab, and then we should get this. Okay, so we'll refresh that. It is running, so we'll click here, and inside of details you can see, yep, we have IPv4. 4. So I'm in a new tab. I'm going to paste that, run it. Okay. So yeah, our instance state is running. It's working. Yeah, one important thing is if you're having issues, um, make sure it's HTTP here. Okay, so next let's do our DIY. So for DIY, we need to launch a second EC2 instance in a different availability zone. Okay, so we'll call our second one web server 2. So let's click launch instance. Call it web server 2. We'll use Amazon Linux again. I'm sure we'll use the same thing as before. T2 micro, key pair, proceed without key pair. All right, so we need to edit the network settings. That's the actual important part. So lab VPC and then subnet, we did 1A. So this time we're going to do 1B. Okay. Type, let's do again HTTP. All right. And then we'll open up advanced details, scroll all the way down, and let's again upload that same file again. And we'll launch this instance. All right. Cool. All right, we'll go to instances. So we have this was our first instance, so let's copy that ID and we'll paste that there. So that's an AZ1. Let's refresh this and we'll take our second instance, which will be an AZ2, and we'll paste that there. Let's see if it works. It still isn't even launched yet. So, all right, yeah, cool. So it works. We got 2 instances and 2 different AZs. So congrats, we finished that. Next thing, let's go. All right, you did it. The island's safe again. Looks great. Blah blah blah. The mayor loves us. Okay, which one of these do we want? Got a castle. Another thing. This is a tough choice. This third one looks like a decent, like, legit house. Let's get that. Okay. Yeah. Nice. Got a little, like, wall thing around it. Cool. Neighbor level up. Alright, alright. Let's see. Alright, I don't care about pets. I don't care about that. Alright, next up, computing solutions. Let's go to computing solutions. Gonna route and go right there. Alright, let's see what you want. Welcome to our state-of-the-art school. Thanks for coming to help us. No problem. It seems like you need help with your class schedules. Yes, we're currently running a class schedule algorithm, but our Amazon EC2 processor has been running out of computing power and memory. This affects other tasks running on our application, which impacts the classroom and study room scheduling system. I think we can quickly provide a more balanced solution between compute and memory by upgrading your EC2 instance. Is your scheduler complex? It's pretty simple for now. We might add some more advanced features in the future. That's fine. If your algorithm becomes increasingly complex, we have high performance computing technologies that you can use to get the most of your instance. What kind of features are you thinking of? Features are mostly related to course selection. Okay, great. I was thinking of some more advanced features for data processing, but in this case, changing your current system's instance should be fine. Sounds great. If we ever want higher, I'll make sure to contact you. Okay, so we are going to change this guy's EC2 instance to a larger instance. Let's get started on helping him out there. So let's see what we got. We got T2 small. What are we going to do in this lab? Explore Amazon EC2 types, filters, connect to. So we want to change the EC2 instance to a larger M4. Let's get started with the lab. Launching my lab up. All right, our lab is ready. Let's go, let's go, let's go. All right, we're gonna open up AWS console now, get right into this lab. Okay, they want us to go to EC2. Cool, 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 cool. All right, here's EC2. All right, what now? Click on instances, okay. Instances. So click details. And then we're going to review those two. Okay, fine. So we have it looks like they have an instance here launched. AWS Computing Solutions. Oops. So click this checkbox to see the details. Has a public IPv4 and an instance ID. Okay. In the left navigation window pane, click instance type. Okay. So instance types. And if that loads, let me make that bigger. We see all these different instance types. 776. So more than when this thing was made. Okay, so they want us to select T3.large, C5.large, and R5.large. So let's look those up. T3.large, C5.large. Okay, that one. So you can like search them like this. And we'll keep the selection. All right, and we want what? R5 dot large. Yep. All right, so we got those three selected down there. Cool. All right, so what now? Review, scroll, click OK. So, sure, review. All right, so there's some info here. The instance family, instance size. What else do we got? Free tier eligible. It's false for all these. The AZs they're in. All right, and then this is probably the most useful part of all this, which is you get the on-demand Linux pricing. So T3.large looks like it's the cheapest out of these three, slightly cheaper than C5 large. Okay, so we reviewed it. So they want us to now go back to instances. So I guess that's to give us an idea of like info, general useful info on those instance types. So click on that, and then they want us to copy our public IPv4. Okay. Paste in that public IPv4, search it, and we have this link here where we get the instance ID T2 small, part of the T2 family. All right, so next we're going to want to connect into it. So you have it selected and then you want to click on connect. Okay, so review it, click on session manager. And now what you want me to, all right, click SSH client. Okay, click back to session manager. Okay, let's just, yeah, they just want us to connect, so click connect. All right, that should load up the terminal. And inside of this terminal, uh, they're going to want us to run a few different commands here. All right, so terminal row. So we'll start off with sudo -i. All right, that gets us into this root. All right, what now? We run cd /dot// home /ect ec2 user /sample. Gets us into the sample app. Now what? All right, so ls, we got all this stuff in here. All right, so detail -lf what? AWS compute solutions log. Compute solutions dot log. Okay. All right, so review this. Fine. Press Control C to get out of there. All right, so Control C. So now what? All right, so go back to the instances, um, and then choose instance settings, and then edit user data. Okay. So we click that. Actions, instance settings, edit user data. All right, so that would take us there. What now? So review that. Okay. All right, fine. So they want us to what? Stop the instance. Okay. So instance state, stop instance. Yes, stop it. All right, so that stops the instance. Yes, stop it. So, okay, you review it and you don't see the public IPv4. And now we can change the instance type. Okay, let's close this. We don't really need that. All right, so refresh this. Stopping. Still stopping. Takes a moment. Okay, all right. So they're saying like they want us to stop the instance, and then you can change the instance type here. And then once you change it, you can start your instance back up. And then you'll get these IPs again. They don't actually, though, do it. So I'm assuming that's going to be in the DIY section. So let's go there. So yeah, change the Amazon EC2 instance to a larger M4.large. So let's see, our instance should be, yeah, it stopped. So actions, instance settings, and somewhere here, change instance type, yes. All right, so T2 small to, what did they want us to make it? M4.large. See M4 dot large. Yes. All right, and nice thing right here, you get the billing. So it's a bit much bigger instance, so nearly more than 4 times the cost per hour. We are going to click apply. And now that we applied it, let's turn our instance back on. So we'll just click the instance and then click start. Click that checkbox and click start. And we will refresh. And it looks like it's running. So let's just copy our instance ID. And if we paste it here and validate, let's see. We did it. All right, so found the M4 large instance now. So let's exit and collect our reward from this guy. Our school is running. Very nice. I'm glad your school is running. What do I get out of it? All right, cool. So it looks like they're giving us a school. Let's see which one looks like the best. This one looks kind of dirty. Uh, it's really between these two for me. So it seems like the soccer court's kind of vertical versus horizontal. I think this one's a better design. I'm gonna take that one. All right, thank you very much. Yeah. Oh, it's a basketball court. 2 basketball courts. I like it. All right. Yeah. So just got some more real estate. And okay, so next we get either we can do networking concepts or cloud economics. Let's go do networking concepts next. So let's see who we got here. All right, I can see you're waving at me. All right, let's talk to this lady and do her networking for her. All right, welcome to our banking headquarters. I'm so glad you came to help. I'm always happy to help. What can I do for you? We recently migrated our services to the cloud, but we've noticed some connectivity issues with our Amazon EC2 instances and databases. Our EC2 instances cannot connect to the internet, and our databases are unable to communicate with our instances. Interesting. Have you checked your virtual private clouds or VPC settings in your route tables? You can check that, and an internet gateway is attached, and that the VPC is set to allow outside traffic. Is that complicated? I'm a little concerned. We need these changes to happen immediately. We can't afford to wait too long for network updates. I understand your concern. Security groups and route table modifications are applied immediately. Also, setting up an internet gateway for internet access can be done in minutes. That's great. But how did my engineers create a VPC without internet access? Isn't that included? In AWS, by default, VPCs are configured with internet gateways and routing to the internet. When you create a new VPC, you can choose whether all or part of the VPC should be exposed to the internet. This way, you can customize your own network security configuration to meet your requirements. Interesting. I'll check with our engineers later. Be great if you could solve these connectivity issues. Will you help us solve our VPC connectivity issues? Yeah, we're gonna help you out. All right, let's get started. All right, so we got our internet, and then an internet gateway and a router, and then we have a public subnet and a private subnet. Inside the public subnet, we have our web server, and then inside the private subnet, we're going to have our database server, and they're going to have their own respective security groups. All right, looks good. So all right, the practice lab. Explore the components that compromise a VPC. configure a route table to be a subnet within a VPC, configure an internet gateway inside a VPC, and configure inbound rules within a security group to control access. And then in the DIY, we're going to change the security group rules to allow traffic over port 3306 into a DB server. All right, sounds great. Let's get right into the practice. All right, let's close that and we'll click on Start Lab. All right, the lab is ready. Open up that AWS console. All right, first thing, looks like they want us to be in US 1, North Virginia. All right, and then go into EC2. So yeah, we're there. Let's get into that EC2. Okay. We click on instances. Okay. And in the instance section, looks like we have a web server and a DB server, and they want us to copy that public IP address of which one of the web server, right? So web server, and sure, I copied my public IP. Now what? All right, so if we try and paste in a new tab, we get the site can't be reached. Paste in a new tab, and it's taking a while, so yeah, probably the site can't be reached. All right, so now what? So the site will time out after a few minutes. To solve this, return to the previous browser. So yeah, timed out. All right, we need to go into the networking section. So we have our web server selected, and we're going to go to networking. What do we need to do in networking? All right, so we need to click on our subnet ID. All right, so if you scroll down, a bit, yeah, you'll see right on here your subnet ID. So we're going to want to click on that. Okay. All right, we're going to go to our route table, and then we're going to click on that route table. So here we go. Just got this open. So if we click the checkbox, and we'll go into route table, we have here a route table. And we want to click into that route table. Okay. So once we click into the route table, so next, click the link name that contains web server. Next to the route table, click the link name. Okay, did that. All right. Close these tabs. We don't need them right now. So this is what we have, and we go to what? Routes. And yeah, I see that. So now what? Want me to edit routes. Okay, so we click edit routes, and we get this page. And the first thing they want us to remove is this NAT gateway. All right, so we'll remove that, and we're going to add a new route. So it's going to be the 000, and we want internet gateway here, it looks like. And we're going to select this one. All right. For target, choose internet, choose IGW, blah, blah, blah. Click save changes. Okay. So that is our internet gateway configured. Now what? So we review, go back to services. All right, it wants us to go back to EC2 instances. Okay. So we can type EC2 and get back there. Click on instances. And we'll click web server again, and now what should we do? So we want to review security, and we have a security group here that they want us to click on. All right, so we'll click that security group, and on the inbound rules tab, click edit inbound rules. For each security group, you can add rules that control the traffic based on protocols and port numbers. Separate sets of rules exist for inbound traffic and outbound traffic. Okay, so we are editing our inbound traffic rules. So we'll click edit, and we get this. And all right, we need to add a new rule, of course. So what is that rule? HTTP. Okay. So where's HTTP? We want that. And then we want anywhere IPv4. And then we want to save that rule. Okay. Now we want to go back into our EC2 instances. And then we want to, again, go to the web server, and we want to copy the, so we'll go to networking, and we're going to copy that public IPv4. And if we paste it, and okay, so we copy that IPv4, and if we now paste it in a new tab, let's see what happens. All right, so we get this page like they showed us. I'm just gonna say like can't connect. Okay, fine. So that is that completed. Now let's do the DIY. So change the security group to allow traffic over port 3306 into the DB server. Okay, so so if we go back in security, that's where we got that security group. So it seems like that's what they want us to add, because I'm reading the hint here and it says using security group, you need to connect to the thing over a TCP on it. Okay, so we click this, we're in EC2 instances. We open that, we go to security, and yeah, we'll click on this security group. And now, so which one are we editing? Is it the inbound or the outbound? Allow traffic over port 3306 into the DB server. Okay, so we'll edit the inbound rule, and we'll click add a rule, port 3306. And we'll leave that as custom. And then the security group, which security group would we be picking? Using saying would it be DB server security group? I mean, all right, they're saying web server security group. All right, I'll save that and see what happens. So if we copy that, All right. Looks looks good. Cool. All right, we'll exit that. Um, so, all right, give me my reward. I'm gonna take this high-rise building. Thank you very much. Close this stuff up. One third done. Um, okay. Let's see what we got. All right, let's do cloud economics next. So, cloud economics, here we go. This might be something billing related. Let's see what this is. Hi there, thanks for coming. I want to set up my surf shop. Cool, man. No problem. My main issue is cost so far. I get much more web store traffic during the day than I do. I think I can cut the number of servers I use at night from 4 to 2. Yeah, that's one of the many advantages of cloud computing. I'm not sure how to begin. Should I mimic my local setup environment? How do I match my current hardware? Yes, you can mimic the current architecture and the online AWS explains how. So can I potentially use systems with fewer resources? You don't need to overbuy for growth. Okay, that sounds promising. Of course, I'll prepare a price estimate. Okay, understood. All right, accept. Let's go. We're gonna prepare your price estimate. Okay, so this is like a traditional IT where you don't want to like over provision. If you like overdo it, your site will always be up, but like you're paying too much, and if you like just do the average, well then you're gonna have these like customers that are gonna be unhappy during the peaks. So cloud should auto adjust and you can perfectly match your demand very closely. Um, so yeah, all right. So what are we gonna do here? Let's go to plan. So we're gonna create logical pricing groups, create weekly, monthly, and yearly estimates for the EC2 instance, and then we're gonna change the EC2 instance type to t2.micro and generate a new price estimate URL. All right. So step one, review the price lab. All right. So for this, we're going to go to this website, calculator.aws. Calculator.aws. All right. So once we get to this calculator.aws, we want to create an estimate. Okay, cool. So create an estimate. Okay. So we're going to click on My Estimate. And we're going to create a group. Okay. And what are we going to be calling this group? We're going to be calling it web servers. All right, great name. Web servers. All right, web servers. Create that group. All right, we're going to add a service. Find a service EC2. So you can see EC2 down there. And then we're going to configure that. So, all right, yeah, so configure EC2. All right, so web server estimate. And then what was the region they wanted? US East, North Virginia. So EOS East 1. And all right, and now we're gonna configure this. So yeah, operating system Linux. And then the workload is going to be daily spike traffic. And it's going to be 7 days a week. And then baseline is 2. And then peak is 4. And then the hours are 8 hours and 0 minutes that it's running at peak. Okay. All right, so scroll down. We're going to set vCPUs to 2. What about instance? For any instance, all right. For GIB and any network performance, and then we're gonna pick T2 dot medium. And next, we're gonna choose on demand. Yeah, so here's some of the options from reserved to spot instances, which have some savings. Okay, so we're just gonna do on demand though. Scroll down, we're gonna click estimated workload. So show calculation. All right, let's see the estimated workload. So we get that table that will pop up. So we want to review that. Cool. Let's close it though. Storage for each EC2 instance. That's in the EBS optional Elastic Block Store. So general purpose, 30 IOPS. Scroll down. And then snapshot frequency would be, they want weekly. And 1 GB. Scroll down. All right, also we have to configure data transfer. Data transfer from internet. And 1 terabyte per month. And then data transfer to internet 5 cents to 9 cents per gigabyte and 100. Yeah, look, the monthly cost shoots up. Make sure you click gigabytes per month, not terabytes. So it's $99 monthly cost so far. All right, so then click on show calculation. Okay, so we'll click that, review it. So 100 gigabytes times 9 cents, $9, calculation. Cool. And then we'll click save and add service. Click that. All right, successfully added Amazon EC2. And then we want to click on the view summary. So after 12 months, it will be 1,191. And then we can click share. Click share. And Agree and continue. All right, we'll copy that URL. Okay, so that's the lab section finished. If we look up that URL, it should take us to our estimate. Yeah, so yeah, we have this estimate here that we can share. Great. All right, so now what? Let's go to DIY. Change the EC2 instant type to T2 micro and then generate a new price estimate URL. All right. So click edit. And if we scroll down, down, T2.medium, where can we change this? Right here. So we'll take T2.micro, and you can see the price just went down to $31. Let's click update. And then we'll click share. And yeah, agree. We're going to get a new URL. So copy that. Let's paste in our new URL and click validate. All right, we did it. Let's return to the city and get our reward. All right, let's see what you got for us. Wow, this all seems so affordable. Glad to hear that. Let's see what award we can. Oh, okay. All right, we get a new vehicle, so we could get this moped, a paper airplane. I mean, I think the choice seems pretty clear. It's definitely, I think the motorcycle, this like Tron motorcycle thing. Cool. Let's see our new motorcycle. All right. Congrats. Close that. All right. Look at that. So, pro tip: you press Shift to get on the motorcycle. Okay, let's see what we got next. So we got, let's do database in practice. Let's go database in practice. I wonder if it's dangerous to drive a motorcycle with a VR headset on. Doesn't matter. All right, let's go. So, Amazon RDS. Hi, and welcome to the headquarters of our insurance company. Thanks for answering our call for help. No problem. How can I help? Our database admin have recently complained that they spend too much time with operational tasks such as patching and managing database infrastructure instead of innovating for our customer. We heard AWS had a solution. Yeah, that's a common pain point. AWS has managed RDS, relational database service called RDS, that removes operational burden. That sounds like what we need. I can have our database admins experiment with Amazon RDS in our dev test. Can it protect from data loss? Yes, it can. It can perform routine backups. Um, okay, but how else can we ensure that our systems are resilient in case of disaster? Using Amazon RDS, you can deploy in multiple AZs. Should a disaster impact one AZ, an automatic failover to the other AZ will occur. Your data is replicated synchronously, so your customer won't see any downtime. This is exactly what we need. We'll deploy our database in multiple AZs. AZs that will have twice the database performance. Well, not quite. Using multiple AZs is intended for high availability and disaster recovery, not increased performance. Okay, so what can I do to improve performance? Our data analytics team is constantly running real-time queries and big data analytics. If you're doing really intensive workloads, you can provide deploy something called a read replica. Read replicas have the same data as your primary database, but they can allow only read operations. You can direct queries to read replica so that your primary database is free to do write operations. Nice, can't wait to see how it works. Can you help me improve our database infrastructure with Amazon RDS? Sure, I can. Let's accept. All right, let's get started. So, all right, we got our Amazon RDS. We're going to be deploying it availability zone A, which will have read only. Then we have availability zone B with read and write, and then availability zone Z as a failover. Okay. Cool. All right. What's the plan here? So launch an Amazon RDS instance, configure multi-AZ deployment, configure Amazon RDS backup, create a read replica of your primary database using a dbt3.extra-large instance. Okay, let's get into the lab. Start lab. All right. Let's open up that AWS console. Now that our lab started. And okay, they want us to go to RDS. Cool. So it's actually right here. So we'll just click that. And what's next? So we're gonna go to database and then create a database once we open up RDS management console. All right, database. Create a database. Create database. All right, we're gonna do standard create and then pick MariaDB. Standard create, MariaDB right there. Okay. Keep that as the default, and then template, we're going to do dev test. All right. All right, scroll down, DB identifier. Type a name for your database instance. This name has to be unique across all DB instances owned by your AWS account in the current AWS region. Oh, what region? Oh, we're in US East 1. All right, so that's gonna be called my database. That's good. My database. The master username leaving as admin, and then we're going to click on self-managed, so create your own password, and then the password is I love learning. So the password we're going to type is I love learning exclamation mark 1 2 3 learning exclamation mark 1 2 3. Cool. What now? Burstable classes. Scroll down a bit. Burstable classes, and you want T3 extra large. T3 extra large. Storage type. GP2. Allocated storage, we're typing 20. Minimum value is 20. Okay. Maximum storage auto scaling. So we want to expand that out and enable that. That needs to be enabled. And the maximum storage threshold, we'll leave that as is 1000. All right, so multiple AZ deployment, create a standby instance. So I'm going to click that here. All right, the VPC stuff. So keep that as default. Keep the subnet as default, and then public access is no. And then VPC choose firewall. All right, what now? Monitoring, we need to clear. So if we scroll down to monitoring, they want to turn this off, and then additional information, also turn that off for enhanced monitoring. All right, additional configuration. Let's open that up. So the initial database name. So if you do not specify a database name, Amazon RDS does not create a database. So we'll specify that, review that, enable automated backups, and then 7 days for backup retention period. Enable encryption, sure. Clear the maintenance. Okay, so don't enable auto mirror. That's no preference. All right, next you scroll down. So scroll down and we'll click create database. Okay. All right, so it says this takes a bit of time. We scroll down, we just click create database, and you see we have it creating. It says your database takes a few minutes to launch. And here they said expect about 15 to 20 minutes to create your RDS database. It's a great time to get a cup of coffee. All right, so give it some time to create. I actually have a cup of coffee already. So let's wait for that to be done. I'll probably be back in like 15 minutes, I guess. All right, so it's been about like 15-20 minutes or so, and now the status is available. So okay, all right, so they want us to click my database, and let's just review the actions. So set up EC2, set up Lambda connection, and then create a read replica. So that's pretty much it. All right, let's do the DIY section. So they want our RDS database identifier, but they also want a read replica database identifier. So create a read replica of your primary database using a DB T3 large instance. All right, so yeah, we'll just click actions, create read replica. So my database, DB instant. This is a unique key. Do they say anything to call it? So read replica called my database read replica. Database read replica. And DBT3 extra large. Okay. So, I mean, should be correct. Let's click create read replica. Um, so this also might take a few minutes. So a lot of waiting in this lab and this DIY. Cool. So we'll wait for that. Okay, so looks like they're both available. We'll just open these up in new tabs, the database and the read replica. So let's see, what do we need here? The identifier. So yeah, just would be the name then. So my database, and what was the other one? My database read replica. So let's try and validate that. Cool, we did it. Let's go get our reward from the city. Let's see what we got. Nice job. I get to choose a building. I'll take the high rise. Thank you very much. All right, Amazon Relational Database Service completed. Okay, let's do our first NoSQL database. Hi, welcome to the best entertainment streaming service in the city. Thanks for answering the call. We want to add more features to our streaming service, which would require a highly scalable database with lightning fast performance. One feature idea we had is to add a digital bookmark so the customers can continue to watch shows where they left off. Can we accomplish this without having a well-defined schema? That would be a nice feature to add. Based on what you described, I think Amazon DynamoDB is the best option. DynamoDB is a NoSQL database, so you don't have to worry about a schema. It automatically scales and it has a single digit millisecond latency. Okay, that might work, but what about gathering metadata on viewing habits from customer devices? Can a NoSQL database organize a large amount of metadata and support the storage of it? It sure can. DynamoDB supports petabytes of data. And to support your metadata needs, you can add records with unique IDs that have varying attributes. Nice. That sounds like it will greatly enhance our customer streaming experience. Can you help us implement this solution? Sure, let's do it. Let's get started. All right. So this solution uses Amazon DynamoDB as a flexible schema, so each row can have a number of attributes at any point in time. Okay. DynamoDB is a key value document database that delivers single-digit millisecond performance at any scale. DynamoDB supports two types of primary keys, a partition key only or a partition key and a sort key. This solution uses a partition key and a sort key. When getting a specific item, you must specify the primary key. Okay. All right, let's go to the plan section. So we're going to create a NoSQL database in the lab. And we're going to add records with dynamic schema to the DynamoDB table, and then we're going to query the DynamoDB table. Finally, we're going to, for the DIY section, create a new user item with a unique ID, and then add a new attribute named rating with a number data type. All right, let's get into the practice. So click start this lab. All right, click open AWS console. All right, so let's get started. So we need to find, we need to load DynamoDB up in the management console. Just search DynamoDB, there it is. Let's open that up. All right, next we're gonna click on create a table. Click that. All right. Um, all right, so we're gonna call the table user video history. All right, user video history. Um, and for partition key, we're gonna have user ID for the partition key, and for the sort key, we're gonna do last date watched. Last date watched. And then our user ID is a string, last date watched is a number. Okay, let's see what we gotta do next. So keep as default settings, and then we need to create the table. Default, and then just click create table. All right, so that'll take a second. Once it's active, we click on user video history. So let's refresh. All right, it's active. Click that. Let's see what we want to do next. All right, so we click actions and we want to create an item. Okay. All right, so we'll create an item. Let's do that. All right, so we're gonna type in this user ID and this last date watched in there. Okay, so we have our user ID, last date watched. All right, we're gonna add a new string attribute. So add new attribute string, and what do we put in this attribute? All right, video ID. So that'll be our attribute video ID, and for value we have 9875 DJC 18559. All right. All right, we're gonna add another string attribute. Preferred language. English. Cool. All right, we're gonna add a list attribute into here. And supported device types for the attribute name. And for the item, we're gonna do a string for the field, I mean. Amazon Fire TV. Let's see. All right, it looks like we're gonna need another field in here with Amazon Fire tablet. Cool. Oh, and then we'll create item. So create item. All right, the item has been saved successfully. Um, so now we'll click on Explore Items. And all right, so we click on our table and we can see our items right there. So they want us to click on this item for the user ID. So we click that and we go back in here. All right, so we can still edit it. All right, so we click add new attribute, choose number, and then we're gonna add in video ID. Okay, fine. Add new attribute. All right, so then we'll click add new attribute. We'll click number. And then, all right, so it's gonna be last stop time. Last stop time. And put 90 as the value. All right, so yeah, like save and close that. All right, so we can open up this scan or query section and we're going to click query. All right, and we're going to query this partition key. So 1, 2, 3, 4, 5, A, B, C, D, 6, 7, 8, 9. And then for the last date watched, we're going to do greater than 1609. We'll run that. So completed, read capacity, 0.5 seconds. So okay, review, fine. What now? Okay, so if we change the partition key to so if we change the partition key to this ABD5 ZXCG12385 in our query and we run it, should get no items returned. Yep, that's because we don't have that. There's no record with that partition key. All right, so there's also scan. Click scan for a second. And if we run that, all right, we get one item returned. So the maximum data set size limit for scan is 1 MB that it can return. So if it exceeds that, the scan stops and the results are returned to the user as last evaluated key value. Okay. All right, so that's the lab complete. Let's do the DIY. So DIY is to create a new user item with a unique ID and add a new attribute named rating with a number data type. Okay, so we'll just click create item. And so they want a new one. So, all right, so I'll call mine ABCD9999 for the user ID. And I don't know, I'll make this 2023. Let's just say. All right, so the thing they want here is a new attribute named rating and a number data type. All right, so add new attribute, number, rating, and we'll put this as 4, let's say. So I'll just copy that because we need this user ID, and we create the item. You can, if we run a scan, you can see now we get 2 things returned. And all right, we need to put the table as well. So user video, what was it called? User video history. So that should be this lab. Let's see if we got it. Could not find a record with user ID ABCD999. Oh, I think maybe it's because I put it's maybe case sensitive. I should have put lowercase rating. Let's try that. So yeah, it's still there. But I think that should fix it. Let's see. Yep, there we go. All right, so that's our DynamoDB part of CloudQuest complete. Let's go get our reward here. All right, we get a building. I'm gonna take the high rising here. Let's collect that. Thank you very much. Nice high rise. All right, NoSQL database delivered. All right, let's see what we got next. Let's do file systems in the cloud. So we'll route and go there. All right, let's see what you want. Hi there, thanks for coming by to help us out. This is an important time for the city. It's only pet modeling agency. All right, Amazon Elastic File System. No problem, happy to help. I love pets. All right, great. Let me explain. In the past year, we set each branch to a local client management. Each server stores images of all of our pet clients along with information, metadata. We use a custom application to sync the client data across all 3 branches, but it takes too much time to access the images and it's not very consistent. I see. Is the storage capacity on each branch server the same? No. Our syncing solution fails sometimes because our branch server might run out of storage space. One more question. Does your team update the same files? Yes, all branches access and update the same pet client files. We have certain folders for our VIP clients. Okay. Based on your answers, I'd recommend Amazon Elastic File System or EFS. It's a serverless set and forget solution that you can use to share file data without provisioning and managing storage. Using Amazon EFS, you can create shared network drives so your branches can access pet client photos from central locations and you can restrict access with file level permission. Okay, sounds good. But what about storage capacity? Amazon EFS provides petabytes scale storage that grows and shrinks automatically as you add and remove files. Nice. We have centralized storage, but what happened if Amazon EFS fails? Would we lose our client data? That's quite unlikely. It's highly available, designed for 99.999% durability. Also by default, the file standard storage. Redundantly store across multiple AZs. Amazon EFS is even designed to sustain concurrent device failure by quickly detecting and repairing lost redundancies. Wow, that's amazing. I think moving to EFS might work. All right, can you create an EFS file system? Will you help create an EFS file? Sure thing. Let's do it. All right, let's get started. All right, Elastic File System. So this solution uses 3 web servers distributed across separate AZs, and the web servers need to share the same unstructured data, and it consists of a PHP file, config file, and plugins and images. So EFS can be used to share file data without provisioning or managing servers. EFS automatically grows and shrinks as files are added and removed, so capacity doesn't need to be managed. Servers access shared data in Amazon EFS by using mount targets in each AZ. Applications on each server view each mounted file system as a local path. So we're going to launch and configure an Amazon EFS file system, mount file systems to Amazon EC2 instances, connect a second EC2 instance, and then share files between two EC2s. And then the DIY section, after the lab, we're going to mount an EFS endpoint to a third EC2 instance and test that those files are accessible from the EC2 instance. All right, let's get started with the lab. Click Start Lab. Okay, we'll open up the AWS console. All right, let's get started. So, all right, first thing they want us to do is go to the EC2. All right, they want us to go to our instances. So, all right, the concept here is we're using EFS, which you can grow and shrink your file systems automatically as you add or remove files, removing the need to like provision or manage capacity to accommodate growth. Okay. All right, so we'll go to instances. We have these 3 instances running. So let's see what they want us to do with those. All right, they want us to click on the pet. Actually, they just want us to review. Okay, fine. And then, okay, there's 1A, 1B, 1C. And then we need to scroll down and click on security groups. Okay. So if we scroll down, see security groups right here. All right, so let's click on security groups. I see 3 here. All right. All right, so review and then we need to create a new security group. Okay. And call it Pet Models EFS1 5G. So that's right. If you scroll up, you get to see the name here. So what was it? Pet Models EFS1. Is it 5G or SG? SG, not 5G. All right. And the description is restrict access to web servers only. Restrict access to web servers only. All right. And VPC, we pick this one, pet models. See where here it is. And we want to click on, for inbound rules, add a rule. Okay. Let's see what we do next. So for type, for this new inbound rule, we'll choose the NFS type. And then we're going to click on this security group web server SG. And then the concept here is EFS file systems require an inbound NFS rule. By selecting a security group as the incoming source, any EC2 instances linked to the security group you select will have NFS client access to the file system. Okay, so we need NFS, and then here we scroll down to our security groups, and there it is. And then what now? So we choose that. Okay, we scroll down, and okay, and then just we create our security group. Seems like we leave outbound alone. Don't change anything there. All right, so should see that, yep, it's created. And now we need to type EFS. So here's EFS. Let's go to there. EFS. Click on that. Let that open. And then once it loads, we'll have a page like this, and we'll click on Create a File System. All right, so click Create File System, and we get this pop-up. So, all right, the name, we're going to call it Pet Models EFS1. And then we need to choose this VPC, Pet Models. All right, let's do that. Pet Models EFS1, is that the same name? Yeah. And then we have our VPC here, the one with Pet Models. And then, okay, we don't click create, we actually click customize. That opens up this like additional setting page. All right, so it looks like we don't want to enable automatic backup, so we'll get rid of that. Then transition into infrequent access IA, we choose none here. Scroll down. So we'll pick none for that. Transition into archive, also none here. Okay. And okay, that will stay as none as well. And then what next? We scroll down, and then throughput mode, we're selecting bursting, and then we click next. So, okay, and we'll click next. All right. And then, yeah, so it looks like it loads also this mount target page. So we're going to remove 1B, 1C, and then we're also going to clear 1A. So let's do that. Remove this 1B one, and you see 1C, we'll remove that, and then we'll also clear the current security group here for 1A. All right, we'll go to next. And then we want to choose the pet model EFS15G. So that's the one we just made. So here it is. Okay, and that's all they want us to do. So we'll click. So we'll click next. All right, looks like they want us to do nothing here for this policy editor thing. So we'll go to next. And now let's see what. All right, and then we'll just scroll down and create. So there we go. All right, so that's creating, and we should get a success alert. And then we're going to want to click on the name of this new one. All right, so we got it. We'll click on this pet models EFS1. And we're going to want to click on attach. Okay, so it looks like we're going to use this command later. So we need to click copy for this this EFS mount helper. So I think we're going to have to do some stuff internal. So make sure to copy this and save that command for later. All right, so we'll close that, and then we're going to go into EC2. All right, so we'll go to our instances, and then we're going to select web server 1, and looks like we're going to connect into that. All right, so which one of these is web server 1? Looks like it's this one for me. All right, web server 1. We're going to click connect. All right. All right, so in Session Manager, you just click on Connect. This should open up like the terminal type of environment. Okay, so let's see what we do now. So we're gonna run sudo I. All right, so we'll write that sudo -I, and now we'll write sudo yum install -y Amazon EFS utils. Okay, we need to install this thing. All right, so that completed. All right, so review it. Looks like it should say complete. Oh, okay. Now in the next step, all right, so in this step, you use Linux commands to create a data directory and then mount the newly created Amazon EFS system to that directory. You create a log file and append information to it. The log file and its contents will be visible from other instances that have the same system mounted. All right, so we're going to run a bunch of commands, it looks like. So the first one, it seems like they want us to make a new folder called data. All right, so we'll write make mkdir to make a new folder, data. All right, and then if you write ls, you should see your data folder. And then what now? Okay, so now they want us to paste that command from earlier, that one we copied. So we'll paste that, but you see at the end this EFS, delete that and replace it with data, which is that name of the new folder we just made. All right. So I don't know what happened. I think it was maybe my internet or something, but I couldn't type anymore, so I just terminated, reconnected, just sudo I to get to that root, and then went into root user, and then went into data, ran this command again, and then I typed in EFS1 mounted in site A, pressed enter, and then I wrote Control C to just get out of that. Um, So, all right, that's step 29. Let's see what's next. So, all right, we want to go back into the management console and type EFS and go back to the EFS place. So, all right. So, okay, let's see what we do next. Um, so we want to go into, we click into this, the pet models EFS one. And all right, click into network and then manage once that loads. So scroll down, go to network, and then we'll click on manage. Um, all right, so click on add mount target. Um, so, all right, review, we have US East 1B, so we're adding other availability zones, it looks like. And for the security group, we choose this pet models subnet 2. So let's find that. Pet models. Which one is it? I don't see it. 10.10.1. Oh, sorry, not security. For the subnet ID, so here we choose that one. Pet models VPC, pet model subnet 2. Okay, so we choose that. Um, and then, okay, we choose the that security group we made earlier, that one. Um, and actually, shouldn't this one also have that security group? It looks like. Seems like it was missing that. Okay, so yeah, they both have the security group. We added in this subnet ID they asked for, and AZ is US East 1B, and then we just want to click on save. All right, I wouldn't worry if you get this error message, that's fine. Just close that. Um, all right, so we'll have to wait a few minutes, it looks like, and then we'll want to click on the refresh, and we should see available for our US East 1B, um, the new mount target we just made. Okay. It's refreshed, see if it's available yet. No, it's still creating. So it looks like it takes a minute or two. All right, just refreshed and now it's available. All right, let's go to the next step. So I go back to EC2 instances, and then we're going to connect into web server 2. Okay. Um, Probably, I'm guessing we're going to do the same thing we did earlier with web server 2. So web server 2, click on connect. Let me close out this earlier session just so we don't get confused. And then session manager, okay, and then click on connect here. So we should connect into that. And okay, yeah, so pretty much the same thing again. We'll type sudo I, we'll install this Amazon EFS utils. All right, so we'll do that. Sudo -I, and then yum install -y Amazon EFS utils. Amazon EFS utils. All right, run that. It should install, and you should get this completed and installed. All right. Next step. All right, we're gonna make a data folder, and we are going to we need to paste again that same command from earlier. So hope you still have that. All right, so let's see. What are we doing again? All right, first we need to make the folder. So make the data folder. Now let's just make sure it's there. Yeah, it's there. All right, we'll go into it, and then paste that thing. Yep, right here. Delete that EFS at the end and replace it with the folder name, which is data. That's the directory. Yeah. Mount point data does not exist. Oh, sorry, my mistake, guys. You see, I went into the folder. I kind of jumped the gun here. So, yeah, we need to go back out for a second. All right. And you see now we're back out where if one layer deeper is that folder, and now we can run this, okay? I tried to run it while I was already in the folder, which you can't do. All right, so we did that. Now we go into the folder. So, all right, cd data. And now we run this cat efs1 setup.log. efs1 setup.log, and that should output that thing we did earlier. Yeah, efs1 mounted in site A. So I guess we now mount another like thing to this log file. We added in like this other one. So sudo bash dash c cat efs1 setup dot log. Right, press enter again, and then write efs1 mounted in site B. Is that good? Yeah, EFS1 mounted in site B. Cool. Press enter, and then write Control C. So Okay, so then we want to run this cat thing again to just make sure they're both there. So if you write cat efs1 setup.log, yeah, so we have mounted in site A, mounted in site B. So that should be good for this. Um, so congrats. All right, we finished the lab. So let's go to the DIY section. Um, so DIY section, mount an Amazon EFS endpoint to a third instance and test the files are accessible from the EC2 instance. All right, so let's click again on this pet models EFS1. We scroll down back to network and let's click on manage for a second. And we're missing our third availability zone 1C. Yep, here it is. So click the subnet ID and then security group. Let's use the exact same one. And that should be all good there. We'll save that. Um, and again, ignore that message. And then just give it like a minute or two to finish creating. All right, so next thing, let's go to our EC2 instance. I will click on our instances. And okay, we need web server 3. That's the third one that we haven't done yet. So we'll click on connect here. And let's go ahead and connect into this one. That should open up the session manager. All right, so once we're in here, the very first command we want is sudo-i. All right, and then we'll run yum, so yum, right, yum install, um, oh shoot, what was it called? Amazon EFS utils. All right, run that one. Cool, so that completed. That completed. All right, so we'll make our data folder. Paste that command earlier, and then change it from EFS to data. That finished. All right, we'll cd into data. And so if you run cat efs1.setup log, see we got 1A. I mean, we got A and B. We need to add in C. So to do that, we go sudo bash -c cat efs1 setup.log, and we press enter, and then we write efs1 mounted in site C. Press enter, control C. All right, so if we run this, should see A, B, C. Okay, we can close this. We're done. Close those. So what do they need? They need our EFS file system ID. So let's go back to EFS and find that. All right, so that should be our EFS file system ID, right? Yeah. So copy that. Yeah, it's like fs blah blah blah. Paste that, validate. Let's see what if we're good. That's it. We did it. All right. So at least three Amazon EC2 instances in different subnets are accessing Amazon Elastic File System. Great. So now we get to return to the city and collect our reward. All right, let's get our reward. All right. All of our branches can access the client photos from one location, and we don't need three separate servers anymore. Choose one option. Is that like a griffin thing on top of it? I'll take the griffin. All right. Oh, it's a dog actually. Cool. That's file systems in the cloud done. All right, on to our next thing. I'm gonna do. Let's do. I'm gonna go do core security concepts. Core security concepts. Here we go. All right. Hello, welcome to the stock exchange. What can I help you with? We recently decided to create a support engineering team. As this team grows, we want to be able to manage users effectively, efficiently. All right, this sounds like maybe an IAM thing. AWS is a service called Identity and Access. Yeah, IAM. You can use IAM policies to manage users and groups. Yeah. So with policies, do I need to learn every type of permission for all AWS services? I just want my support engineers to have read-only access to EC2 and RDS. Yeah, you don't have to do that. Or they have pre-built policies. So yeah, there are some pre-built. There's a bunch of pre-built read-only policies. So yeah, this should be no problem. Um, and yeah, you can create your own custom policies. There's a tool to help you do that. So she says, sounds like there's a lot of options. Yeah, there are. Um, you can assign them through AWS Management Console, the CLI, or developer tools. Thanks, that sounds promising. Can you show us how to get started in creating users and groups for the support engineering? Sure thing. Let's do it. Um, all right, so here's the video concept. Sorry, what are we doing? This solution uses IAM to create a support engineering group with limited permissions. So you have our users, and they have just certain permissions to these, to RDS and EC2. Looks like they're going to get a group with read-only and also an RDS read-only access. Cool. So, what are the lab goals? It's to create an IAM group and users, and then attach the AWS managed policies to a group of users. And the DIY, we're going to grant the support engineer group read-only access to RDS. All right, sounds good. Let's get started with our lab. So we'll click Start Lab. All right, this lab took a little bit to provision. It took almost 4 minutes before the lab actually opens. So we'll open up that lab and let's get started. So what's first? All right, first they want us to go into IAM. So it's right there. Let's open up IAM. What now? All right, so we go to user groups and we're going to be creating a new user group. Sounds good. Click on user groups and we'll click on create a group. Okay, what are we going to be calling this group? Support engineers. All right, so support engineers. So we'll scroll down and okay, so first thing she mentioned is we want to attach the right permission policy. So they want EC2 read only. So if we write EC2 read, you can see you'll find it right here, Amazon EC2 read only. So check that one. and you'll see you have one checked right here. And then that's it. That's all they wanted us to do here. So click on create group, and then it will start creating it. All right, and you'll get this support engineers user group created. So sounds good. Next, we're going to go to users, and we're going to create a user. So click users, create user, and all right, what are we? We're going to call our user support engineer 1. Support engineer 1. And then we are going to provide them access to the AWS management console. And we're not going to auto-generate. We're going to create a password, and the password will be support engineer exclamation mark 123. All right, so user must create a new password at next sign-in. That's recommended, but we're not going to do that. So I'll like force them to create a password. And then we're going to choose add user to groups for permission options. So we have to click next and add users to groups, and we'll select this support engineers group. And we'll click next. They do want us to add a tag. All right, so we'll add a new tag, job title, and it was what, support engineer. And yeah, that's it. So we'll click create user. All right, so user successfully created. We have this console sign-in link. The username is going to be support engineer 1, and the password is this support password exclamation mark 123. Cool. So, all right, they're going to want us in a new tab to sign in. All right. So copy this, and we'll open a new tab. So I think it might log me out once I open this link from here. So let's just see. Let me just copy that password before I run that. All right, so in a new tab, we're going to go to that sign in. Paste that password in here, and yeah, you can see that it logged out here. So the IAM was what? Support engineer 1, right? And we'll click sign in. And yeah, we signed. Now we're back signed in as in the management console, but we're signed in as support engineer 1 now. So, all right, we're going to go to EC2, and we're going to make sure we're in US East 1, and then we're going to go to instances. And it looks like they want us to try and terminate an instance to make sure it works. So let's do that. We'll go to EC2. And we'll go to instances running, and then let's try and terminate this web server. So yeah, terminate, click terminate, and we should get a warning message if we did this correctly. So we'll give that a try. And yes, you see, failed to terminate. We're not authorized to do that. So that's because we gave the group just of read-only EC2. We didn't give it the option to delete them. So that's it. That's the lab. So, all right, in the DIY section, they want us to just add the read-only to that support engineers group, we need to add in the read-only access to Amazon RDS. Um, so I'm curious, can we go to IAM from here? Can we? So we'll go to IAM and groups. Yeah, we don't have access from this support engineers one user. Okay, so we'll close this for a second. Um, what if we click reload here? We get back in the root user. No. All right, let's close that. And we'll try and open up the AWS console. I need to get back to my um, okay, looks like we're back. So yeah, you just close that new user, the tab for that new user, and if you click back to open AWS console, that gets us back in here, and now we have full access. We're back to like a root user. Um, so if we go back to IAM and we go back to user groups, and then we'll want to click on support engineers and let's see, permissions. Yes, permissions. So we'll want to click add permission, attach policy, and they wanted RDS, but read only. Yeah, here we go. So this one right here, Amazon RDS read only access. So we'll attach that policy and we should be good. The thing we need to do is just put the name of the user group. So it's support engineers. We'll just paste that in here, click validate, and let's see if we did it. We did it. All right, so we gave them the right permissions. So if we click exit, and let's talk to her and get our reward. So thanks for building this. Please choose a reward. I'll choose the high rise. So we'll collect that. Nice. That's core security concepts completed. And here's our helipad that we just got. All right, on to the next one. All right, so next we're going to be doing auto healing and scaling applications. So let's route and go to do that. All right, here we are. Auto healing and scaling applications. All right, so this is going to be an EC2 one. All right, so hi, I own a gaming cafe. Cool, I'm a gamer too. Gamer parties are so hot right now. We have a maximum number of EC2 instances that allow users to provision each day, but we do not have controls to enforce this rule. So we have a couple of issues. First, if an EC2 instance crashes, we have no automatic way to replace it. And second, we want users to stay within their server provision limit. Okay, so that is going to be auto scaling groups. So here we go. We can set up a template for your user game web servers. In those templates, we can configure the number of EC2 instances to scale up or down based on demand. And we can also have hard limits on the number of instances. Okay, that sounds great, but there's another issue. There's a large party booked from 8 p.m. to 1 a.m. every Tuesday. How can we ensure the user game servers start up and shut down at specific times? So it's going to be user auto scaling groups. So you can configure scheduled scaling. All right, so I think that works for us. Can you configure auto scaling groups? Yes, I can. Let's do it. All right, so we'll get started here. So some videos here on EC2, Amazon well architected. There's usually a bunch of questions about that on the Cloud Practitioner test. All right, so let's just get right into it. So we're going to create EC2 auto-scaling groups in the lab, and then we're going to also assign EC2 instances to the auto-scaling groups. And then in the DIY section, we're going to configure an auto-scaling policy to scale down to 0 resources at 1 a.m. every day. All right, sounds good. Let's get started. So we'll click Start Lab, and we'll let the environment get provisioned. So this can take a minute or two. All right, we'll open up our AWS console and get started here. Okay, so first thing, we need to go to EC2. Cool, so we'll go there. And now what? So we'll click into our instance ID, and then we need to copy the public IPv4. So we'll click on instances, go into instance ID, and we'll copy this public IPv4. All right, so next, all right, so we're just gonna open it up, and you should see a page like this for some game here called The Hunt. Paste that, go. And yeah, here it is. I once tried to run this, but I don't think any of this actually does anything. But yeah, here we go. The Hunt. So what now? We go back to instances and we choose our instance game server, and we're going to create an image. Okay, fine. So go back to instances, select game server, actions, and then there's this images and templates. Click that, click on create image. So that gets us to here. So we'll call the image name game server. So all right, this is going to be our regular customer game server. And scroll down for tags, tag image and snapshots together, and then we create the image. Okay, so that's already selected. Click create image. What now? So okay, that gets created, and now we go to AMIs, and we review here to see that it was created. So you'll have this one that we just made, game server. And yeah, okay, it's here. You see that? So then we go to launch template. Launch template. So we'll click that. And it takes us to this page. So yeah, we're going to create a launch template. Let's click that. And we're going to call it game server template. And we're going to provide guidance to help me set up a template that I can use with EC2 auto scaling. All right, so we'll do that. Game server template, template for regular customers, and yes, click that checkbox. All right, so next, what are we doing next? We'll scroll down to my AMIs, and then we're going to choose owned by me, and we choose that one we just created. So here we go, my AMIs owned by me, and here's the one we just created. All right. Scroll down, And then for instance type, we're going to do t2.nano. So here we go, t2.nano. And then we're going to create a new key pair. So scroll down a bit, and here in key pairs, click on create a new key pair. We'll call it game server key pair. Game server key pair. And then key pair type, we leave as RSA, and then we'll leave as the private key file format as a .m. And then, yeah, and then that's all they want us to do. So we'll click create key pair. That downloads something up there. All right, we'll scroll down to network settings. And yep, that's right here. So don't include launch template. We'll select an existing security group, and we're picking this web server security group, okay? So here it is, web server security group. So select that one. And then next step, just scroll down, review, and then create launch template. So yeah, and here it is on the right side. We'll create our launch template. All right, so success, that was created. All right, so we're now, yeah, we're on the same page here. So we have, if we scroll down, we also have view launch templates. So yeah, they want us to click on view launch templates after we created it. So let's read the concept really quickly. The launch template can be used to configure the auto scaling and healing properties of your system. When a server goes down, the information is used to create a new instance. All right. So, all right, the next step, we're going to need to click on auto scaling groups, and we're going to create an auto scaling group. So if we scroll down on this left-hand side, you'll see auto scaling groups. And we're going to click here on create auto scaling group. So click that. All right, let's just read this really quickly. So using AWS auto scaling, you can build scaling plans that automate how groups of different resources respond to changes in demand. You can optimize for balances between availability and cost. AWS auto scaling automatically creates all of the scaling policies, and it sets targets for you based on your preference. So here we're probably going to do that thing with like the times. All right, so let's just get started. So first, auto scaling group name, we're going to call it regular customer game server. Regular customer game server. And then for launch template, we're going to select our template, game server template. Scroll down and go to next. And we're going to choose this VPC here. And then we're going to choose 1A and 1B. All right. So scroll down. So which VPC? We're this one, auto healing and scaling game server VPC. And then we'll need 1A and 1B. So select both of those. And then, all right, we'll go to the next step. And all right, so we'll click next. And we want no load balancer. Scroll down. Health check grace period is 240. So, all right, go to next. Next. So desired capacity, we want to be 2. And then the min desired capacity is 2, and the max desired capacity is 4. 2, 4. And then target tracking scaling policy. So we'll select the automatic scaling. We're going to select this one. Okay, next step. So do CPU utilization for the scaling policy name. Metric type, average CPU utilization, target value 70. Okay. All right. Scroll down. Scroll down. All right. So click on skip to review. And we'll scroll down and click create auto scaling group. All right, so we created that. So after you create a scaling group, Amazon EC2 auto scaling starts evaluating the policy against the metrics that you selected. So we're going to click into that. So we'll click into the auto scaling. Let's just refresh it. All right, so we'll click into it. So review should have activity history. If we click activity, yeah, so we have that the same activity history. So we'll go to next. Click on automatic scaling, and we want to create a scheduled action, which is all the way down here at the bottom. And all right, so we're going to do that second wave of regulars. Second wave of regulars. And the desired capacity is 3. The min is 3. The max is 4. And the recurrence, we want every week. Time zone I'm leaving as etc. And then, all right, for this 6th step, you have to choose a future date and then type 20 o'clock. All right, so click on the calendar, choose a future date. Today's Friday right now as I'm recording this, so I'm going to choose Saturday, and then I'll type that. And then, all right, so that's all they want us to do. We'll just click create. All right, so yeah, we review it. We have a scheduled action. We made that one. So that's the DIY section. I mean, that's the lab complete. So now we'll go to the DIY section. So DIY section, configure an auto scaling policy to scale down to 0 resources at 1 a.m. every day. All right, so we'll create a scheduled action and we'll call it 1 a.m. and we'll click 0 for the desired capacity, min is 0, and max is 0. And what it was every day. Also pick a future date, and it was at 1 a.m. So we'll write 1 a.m. right here. And let's click on create. Given start time is in the past. Hold on. All right, let's try Sunday. All right, so that worked. So that was our scheduled action name. And then our auto scaling group name was this one, regular customer game server. So let's see what happens if we click validate, if this is right. Yeah, so that's it. You have an auto scaling action scheduled to scale down the instances to 0 at 1 a.m. All right, so that's it. Let's go talk to this guy for the reward. I'm going to take this 3-tiered building thing and we'll click on collect. So it's like coffee place. All right, that's auto healing and auto scaling applications completed. On to the next one. Next one, let's do high availability web applications. All right, hello there. High availability web applications. All right, hi, thank you for answering our request. We just had a disastrous promotional event. Sorry, what happened? So they had an increase in web traffic that overloaded the website. All right. And our EC2 were also hosted in an AZ that was affected by severe storms. We were offline. Yeah, that sucks. Sucks to be you, I guess. So what now? You can use an AWS, create an auto scaling group across multiple AZs to ensure your resources aren't isolated. Second, we're going to create a load balancer so that network traffic is distributed equally across your traffic. So, all right, let's see what she said. If I spread instances over multiple AZs, will that make us 100% safe from failure? Well, no system's ever 100% safe, failure proof, but AZs reside in distinct locations, and a singular event is, it's unlikely to affect both AZs. So after you spread your EC2 over multiple AZs, you can attach a load balancer to ensure high availability and elasticity. You can also monitor your EC2 health by setting up a health check on your load balancer. Sounds promising. Can you build this system for us? Sure, man. Let's do it. Let's get started. All right, high availability web application. All right, so here's the diagram. I'm going to skip this and go right into the lab. So what's the lab goals? We're migrating an auto scaling group behind an application load balancer in 1AZ. We're setting up load balancer health monitoring for an automatic EC2 auto scaling group. And then we're adding a second availability zone to the EC2 auto scaling group. So that's our lab. And then our DIY, we're going to configure an auto scaling group to include a new EC2 instance in a third availability zone. Okay. All right, let's get started with the lab. So this lab's a bigger one, the high availability web application. You can see there's 46 steps here. I'm gonna let this, the environment's just being provisioned. It can take a few minutes. Once it's ready, we'll get started with the lab. All right, just opened up my lab and let's get started. All right, so we need to go into EC2. And then we're going to need to go into auto scaling group. So let's open up EC2. And if we scroll down, you'll see on the bottom, there's this auto scaling group. So go ahead and click on that. And we're going to choose this travel agency web server, and then we'll get some information down here about it. So click that and just make this a bit bigger. And here we go. We have some info on it, the name, desired capacity, min capacity, max capacity is all one. Okay. All right, so we'll go into instance management here. So here we go, instance management. And they just want us to review it. Then we want to go back into details, scroll down. All right, review it, sure. Okay, finally doing some stuff. So we're going to go into load balancing and we're going to click edit. Click load balancing, edit. And we'll click on add a new load balancer. Okay. We're going to choose application load balancer. It's already chosen. And then we'll choose internet facing. So it must be, oops, sorry. So in the concept section, the load balancer must be internet facing if your web applications are for public access. All right, so let's find this load. Here we go. If we scroll down just a little bit, you'll see this availability zones and subnets. So we want to select all of these 1A, 1B, 1C, 1C. And then for the 1C, we want to choose let's see. All right, so for availability zones and subnet, choose the 3 checkboxes. On each of the 3 drop-down menus, choose the available public subnet. All right, so let's first do that. So we checked all of them, and then we want public, so that's already selected, but this third one is selected as private, so we need to change 1C, there we go, to public. So that's done. Next, we need to choose the default routing, create a target group. So where's that? I don't see that. Oh, here it is. Listeners and routing, default routing forward to create a routing group. And we leave name as is. and we'll just click on update. Cool. So let that update. Auto scaling group updated successfully. Um, and now we need to click on security groups. So we'll do that. And we'll click create security group. And we'll call this security group travel agency load balancer. So if we scroll up, you'll see where we get to name it travel agency load balancer. Um, so the description of this is it's going to allow access to travel agency load balancer from the internet. All right. So describe it. Allow access from travel agency load balancer from the internet. Um, and VPC, we select the travel agency VPC up here, you see it. Click that. And then we're going to add an inbound rule. So we scroll down a bit, inbound rules, we want to add one. And the rule, we're going to choose a HTTP here. And the CIDR block, we're going to choose this 00000, which is just going to allow all traffic. Source, I believe that we have to click custom. And yeah, okay. All right, so that's now our outbound rule. We're going to, so all right, we have our inbound rule, HTTP custom, and then we have this 000 CIDR block. Now we have our outbound rule. So our outbound rule also HTTP. Yeah. And destination custom, but let's get rid of that. And if we scroll down a bit, and here we go in security groups. For the outbound one, we pick a travel agency web server. So that should be that done. And then we'll just scroll down and create this security group. All right. So your inbound, outbound rule should look something like this. Click on create. Oh, hold on. Our inbound rule had a problem. We have to click that. All right, so that's fine. I guess it'll just be anywhere IPv4, not like the custom, like the way they had it. It's fine. So it'll actually look like this. Your inbound rule has that CIDR 0000 HTTP, and then your outbound rule HTTP. Destination is custom, and then we'll pick you pick that security group. Create. So that created successfully. So all right, next we're gonna click on security groups, and we want to select this travel agency web server and edit the inbound rule. Fine. So where's the security groups? If we scroll down a bit, I just passed it. Here it is. So this one, wait, was it the load balancer or the server? It was the web server. So here we go. Travel agency web server. Select it. Actions. Edit inbound rules. So what do we want to do? Oh, you want us to, all right, delete that rule? Okay, deleted. Done. And then add a new rule. Okay, sure thing. So I'll add a new rule, and we're going to choose HTTP, and then we're going to choose travel agency load balancer. All right, HTTP. What we find from here, travel agency load balancer. Next step is just to save that rule. Okay. All right, so we'll go to load balancers, and then we're going to click on the travel agency's web servers 1. So where here it is. In load balancing, you'll see load balancers right here. Click on that. And let's just make that smaller, and we'll click here on this one. Travel agency web server 1. All right, so next they just want to scroll down, and we're going to go to security, and then we're going to click on edit. So scroll down, here we are, security and edit. We go in here. So we want to deselect this one. So we'll get rid of that. And then we're going to click travel agency load balancer. We're going to choose that one, travel agency load balancer. Okay. And then we'll save that change. Okay. And they want us to, so we get successfully created. And then they want us to click on copy this DNS name. So I'll go ahead and do that. Copied. Okay, if we paste it into so we copy this DNS thing, and if we paste it in a new tab, you should get the like travel agency site. Let's see if we get it. So yeah, we get the Unicorn Travel Agency. So if we write /health, we should get instance is healthy. So we'll try that. Right, /health. And yeah, instance is healthy. We're going to go into target groups. We're going to choose the travel agency web servers 1 and go to health checks and edit it. All right, so let's do that. Where are target groups? It's in load balancing, target groups. We'll click that. And we want to go to health checks, and we'll click on edit. And we're here, the associated load balancer periodically sends request. Okay, so what do we do there? We just change that to /health. So write that /health. And then we'll open up the advanced settings here. And we're going to change a few of these. So unhealthy threshold, we'll change to 2. And then timeout will be 2 seconds. And our interval will be 5 seconds. And then we'll save that. All right, so next we'll go into auto scaling groups. And then we're going to choose this travel agency web servers, and we need to edit the network. All right, so we'll do that. So we choose this, and if we're in details and scroll down, it should be network somewhere. Here it is, network. So we'll click edit. And need to deselect the current public subnet 1, and we'll make it private subnet 1 US East 1A travel agency VPC. So yeah, it's public right now. We deselect that, and it's this one, right? USA 1 travel agency VPC private subnet 1. And you can see it has the same IP as well. So yeah, here we go. And just click on update. Okay. Okay, so we need to go back to our instances now. And choose an instance. And it looks like we need to terminate it. All right, so choose that. And they wanted us to review network, like to look at networking. So, okay, yeah, I see it. There's public subnet 1 here, sure. But all right, so we'll do what they say, terminate it. And all right, so we'll terminate it. We'll get this pop up, and then just click terminate. Let's refresh. And it's shutting down, so it might take a second. And it should like auto create a new one if we did this right. Okay, I was a little worried for a second because there's nothing there, but okay. It looks like the new instance is running, so we didn't screw up this lab. Let's keep on going. So we'll choose the new instance it created that's running. And if we go to networking, we're not monitoring networking. So, okay. Yeah, where's our subnet ID is not, oh, wrong one. That's the terminated one. Look at this one, the running one. And yeah, we have the subnet ID here. Okay, so like what now? All right, we're going back to auto scaling groups. And we'll go into activity. I remember before there was only 2 things in activity, so looks like there's some more things now here. So yeah, we can review the new activity where we launched a new EC2 instance. So each item in activity history lists an auto-scaling action and the cause of the action. And if I refresh this from earlier, we also get that it's healthy. So fine. All right, we'll go back to auto-scaling groups now. Yeah, I'm already in here. So what now? We're gonna click on network, okay? So let's scroll up. It should be in details. You see I have the travel agency web server selected, and we'll click on, yeah, click on edit network. And what for subnets, choose subnet private, subnet 2, both lab private subnet 1 and subnet 2 should be selected. So right now we just have private subnet 1. We want to also select private subnet 2. So that's going to have both of those selected. And you can see it has that same IP. All right, so we'll click update now, and you can see it successfully updated. So all right, back to auto scaling groups, and we choose it, and then click on edit. Edit what? Edit the group details. Okay. And the desired capacity 2, and then the min 1 max 2. So we'll change that to 2, and then the max is 2, and the min is 1. So we update that. And so we choose it, and we'll go into activity again, okay? So let's look in activity. So review activity, like some, let me maybe refresh it. And yeah, there's another activity because we changed the amount of EC like instances, so it launched another one. All right, so it looks like in the activity, launching a new EC2 instance just happened. We have some new activity. Okay. Let's see, we go to instances, and they just want us to review it, so we can go ahead and do that. And if I refresh, yep, all right. So, okay, looks like this one's still initializing. Just want us to check if it says it's healthy, but all right, fine. Let's move on to the DIY. So what do they want us to do for DIY? They want us to configure an auto-scaling group to include a new EC2 instance in a third availability zone. Okay. So all right, I think we have to go back to auto-scaling groups here. And we'll click on this. And first thing, let's change the capacity to 3 and a max of 3. And then also let's go into networking and edit this. So we have 1A, 1B. Let's add C. So private subnet 1C, we'll add that in. Let's update that. And I think that should be good. So what do they need? They need your application load balancer name and your auto scaling group name. So this is our auto scaling group, the travel agency web server. And you want my application load balancer. Okay. So our application load balancer is just travel agency web server 1. So let's validate. Let's see if we're good. Yeah, we did it. So all 3 availability zones are covered by the instance behind a load balancer. Now we get to return to the city and collect our reward. Okay, so increased traffic is no longer an issue for you. I'm going to take that building for my work. Thank you very much. All right, so that's highly available web applications in CloudQuest complete. Let's move on to the last one, which is connecting VPCs. So that's what I saved for last. Let's go do that. All right, connecting VPCs. Hi, I'm the Chief Marketing Officer. So let's see. We wanted a logical isolation of our application, so we set up separate VPCs for our marketing, development, and finance departments. However, all departments depend on getting reports from finance. Due to isolated VPCs, the team members in marketing development need to raise tickets to gain finance reports. All right, so Amazon VPCs offer a feature called VPC peering. After you create a peering connection between two VPCs, you can route traffic between the VPCs by using private IP addresses. All right, that sounds good. Great. Can I peer one VPC to multiple VPCs? Yes, you can, but peering connections are not transitive. This means if you create a peering connection from marketing to finance and development to finance, no traffic is allowed between marketing and development unless you create another peering connection between them. Okay. You can also peer with VPCs in different accounts. Are you using different accounts for your VPCs? No, we are currently using. We aren't. Okay, that's good to know in case we add more accounts. Can you help us improve access to our finance workloads? Sure. Thanks. I can't wait to get the financial data that we need. All right, let's get started. We got this finance VPC here, a marketing VPC, and a developer VPC, and we need to do some sort of VPC peering. So let's just get into this. So the practice lab goal, set up a VPC peering connection, ensure that traffic is internally routed within this connection, and then we need to, for the DIY section, we need to configure VPC peering between developer and finance department VPCs. Okay, we'll get into the lab. So let's click Start Lab. Okay, let's open up our AWS console and get started with connecting VPCs. All right, so first thing, we gotta search up VPC. Okay, so search VPC. Click on that. All right, so while that's loading, let's just read the concept. So Amazon Virtual Private Cloud, or VPC, is a service that helps you launch AWS resources in a logically isolated virtual network that you define. So you have a complete control over your virtual networking environment. Okay. So we go to your VPCs and we should see the same thing they have. So yeah, we have a developer VPC, a marketing VPC, and this finance VPC here, like this. Now we'll also read the concept real quick. So by default, VPCs are isolated from each other. A VPC peering connection is a networking connection between two VPCs that you can use to route traffic between them by using private IP addresses. So that's necessary with VPCs since they're isolated. We need to use this peering connection. All right, so we'll go into EC2. And once we load up EC2, we should see our server. We should see, all right, so we went to EC2 and let's go into our instances section. And we'll see in instances, we have a marketing server, a finance server, and a developer server. Yeah, and they want us to choose the finance server and review that for a second. So if we choose the finance server, we'll see that there's nothing here for the public IPv4. We have this private IPv4 address. Let's go ahead and copy that address, that IP. We're gonna need to copy that. And then, okay, we have the subnet ID, sure. And okay, so what we need to do, we need to click on our marketing server and connect into that for the lab. So we'll go ahead and do that. Click marketing server and we'll click on connect. And then inside session manager, let's just go ahead and click on connect. So session manager will load, connect it in, and then they'll want us to ping that IP that we copied from the finance server. So if I write ping, and then we'll paste that in, and if I run this, it's gonna ping it for a bunch of time, and then eventually we'll press Control C, and you'll see like 100% packet loss, and yeah, it'll just say the IPv4 address for the finance instance. This command checks the connection to the finance server. Review to see that your command hangs there and there's no connection. And then to exit, you press Control C. So press Control C, we exited. So yeah, we can't really get in there. Right now, we need to do the peering thing. So, all right, we'll go back to EC2 now. We'll close the session manager and we're going to open up the marketing server instance ID. So here it is, marketing server instance ID, open. What now? We need to click on our subnet ID. So click that. And then we're going to need to go into the route table. Okay. So how do we do? All right, so to do that, we click here. We should scroll down and we'll see route table. So we'll click that. And okay, we'll click the checkbox now. If we click routes, they're gonna want us to edit the route. So we'll click on this. Routes, review it, click edit. So okay, in routes, here we can review it. Okay, whatever, review it. Let's just do, what do you actually want me to do? You want me to go to the peering connection here, and we need to create a peering connection. So, all right, here's the good part now with the peering connection. We need to call it marketing finance. That's what we're going to call it. Select a VPC. This is going to be the requester. So in this case, it's going to be marketing. And then we need the acceptor. So any guess who? It's going to be finance. So yeah, so that's that done. And we're just going to click create peering connection. All right, so once that's done, you get success and then pending acceptance. So yeah, the next step right here, you click on actions and then you accept the request. So we'll go ahead and do that. Here we go, actions, accept request, and then just click on accept. So boom, bang, done. What's next? Okay. Yep, we accepted it. All right. We need to go back into instances. So we'll go back into EC2. We'll click back into instances. And we'll want to click on marketing server and scroll down and click on the subnet ID right down here. All right. So before we continue, let's just review the concept before we get into the stuff we need to do in that subnet. So the concept. So after you establish a peering connection, you must modify the route table associated with each VPC. So I guess in this case, marketing, and then also finance. And you must add a route into each route table to allow traffic to be routed to the peered VPC. All right, so subnet, we'll click the checkbox and then we're going to click on route table. So here we go. We're in that marketing VPC and we'll click on the link to the route table here. And then we're going to want to click on the checkbox again and we're going to want to click on routes and we're going to edit the route. So go. So you see they do the same thing. They click checkbox, they click routes, edit routes in CloudQuest. All right, this is the part that you might have gotten stuck on. At least this is where I got stuck. So yeah, they ask you to click add a route, put the IP address, and then select the peering connection. So I do that, and I click peering connection, and we have our IP address from earlier. You see it's the same one. Do /16. All right, there we go. So hold on. 3100, right? This is it. 172.3100/16. And peering connection, marketing finance. And then we'll click save changes. Let me tell you why I got stuck so badly on this step the first time I tried doing it. I forgot this /16 at the end. That's very important for the cider block. You gotta have that. So this should be good now. Let's try and save the change. And yes, we got success. All right, very nice. So yeah, we got success. Now they're going to want us to do finance server. So let me close up this, and we're going to click the checkbox for the finance server. And it's going to be the same stuff again. We click our subnet ID, and it's going to load up the VPC console for the finance VPC. We're going to click the checkbox. We're going to scroll down, route table. We're going to click this, and then we're going to click the checkbox again, go to routes, and we're going to edit the routes. And we're going to need a new route. So let's see which one they want us to put. So you can see finance. That's what we're doing right now. All right, 10.10.00.16. So go ahead and put that in. 10.10.00.16. Did I get that right? 10.10.00.16. And we check, we get that it's peering connection again. Yeah. And we get that marketing finance peering connection that we set up. And we're gonna go ahead and save the changes right here. And okay, we got another success done here. Very good. So I'm guessing they're gonna want us to try and ping the marketing server to ping the finance server again. So let's go do that. We'll close that. Don't need the route tables anymore. We just need to go back to EC2, and we'll select marketing server, hit connect, session manager, go ahead and click connect. And we're gonna ping that, right? Is that what they want us to do? Let's see. Yeah, that's looks like that's what they want us to do. So sure thing. And we're gonna ping it. Let's see. So the session manager terminal for the marketing server instance opens in a new browser. In the terminal, replace the current IP address with the IP address that you copied earlier. So yeah, did that. Review that. And we get the same thing. Review to see that the ping command is still not working. Okay, so if I press Control C, yeah, I guess it's still not working. 0 received, 100. Yeah, I think that means it's not working. So let's go to the next step 34. Concept. Security groups do not automatically accept data from peered VPCs. You must update the security group to allow a peered VPC as an incoming source. So we need to do some editing to the finance server. So let's close the system manager. click finance server and go to security groups inside of security. Um, yeah, click that. Click inbound rule, and we're gonna edit the inbound rule. All right, before we continue, let's just read this concept. So security groups are stateful. If you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound rule. This also means that responses to allow inbound traffic are allowed to flow out regardless of the outbound rule. All right, let's just edit this. And we need to add a new rule. It's a custom ICMP IPv4 source type custom, and we're going to type the same block, so 10.10.0.0/16. And we save that rule. All right, and now if we go back to our EC2 instance and we go back to marketing and try and ping it, it should work now. Let's see. So click connect, connect. So we're back in the marketing session manager, and let's see if we can ping that IP. And yeah, looks like it is working now when we ping it. So yeah, it's getting received. So all right, all good. Let's get into the DIY section. So the DIY section, configure VPC peering between developer and finance department VPCs. So they're gonna need the developer instance ID and the finance instance ID. So let's copy these, finance ID and developer instance ID. And if we click validate, see if it works. It shouldn't work now. Yeah, could not find a peering connection between the developer and finance VPC. Check the VPCs, try again. All right, let's go into developer and open up the subnet ID for developer. And we'll open up peering connections, and we're going to create a new peering group. So we'll call it developer finance space. Developer finance. The requester is going to be developer, and the acceptor is going to be finance. And yeah, that should be fine. So we'll create the connection, and then we need to accept it again. So we're going to click accept request and just click on accept here. All right. So requester, CIDR, and acceptor, CIDR. All right, I'm gonna keep this page here. We might need to come back and get these. All right, so in the VPC, I just clicked on subnets. And if we click on route table, I'm right now on the finance private subnet 1. They also have a public subnet, but we're looking at the private one. So we'll click on edit route. And you can see we have this peering connection from earlier. And if I go to the marketing finance one, you can see it's the requester cider in here. So we need the requester cider from that developer finance one that we just created. So that's this one. It's going to be 192.168.00.20. So we're going to create a new route and we're going to paste that in. That's going to be the destination we need. We're doing another peering connection, and this time we're doing developer finance. So that should take care of finance. Now next we need to edit our developer subnet. So which one are we doing? I'm not sure. We have 2 public developer subnets. Struggling a bit to figure out which one we're editing here. Let's see, if we click developer and we scroll down, it looks like they're using subnet ID 2. So we'll click that. I guess we're going to do the subnet ID 2. So click the check box on the subnet and you click route table, and then we'll click the checkbox and we'll go to routes and we're going to go ahead and edit route. So we're going to add a new route. It's going to be, again, peering connection, and that's going to be the developer finance one. And not marketing finance. If we go back to here in the developer finance peering, we gave the requester cider. Now we need the acceptor cider here. So that's what's going to go inside of developer. So save this. We should be good here. Let's see. Let's try and validate. Yeah, we did it. So the instances are connected through VPC peering. Now return to the city and give your customer the good news. So that's it. So let's go talk to them and we'll get our reward. I'll take this tall building. That one looks kind of like an IRS building, the second one. I don't know that. Yeah, all right, great. So that's that. That's my Cloud Quest playthrough finished. And this was connecting VPCs. This is definitely, I think, one of the harder ones in Cloud Quest. I hope you enjoyed following me and Pinky Cloud along.